In today's video, we'll be exploring the concept of transposition. Now, some of the questions that we'll be answering today include: what is transposition, how to correctly label an equation, and how to transpose an equation to make a given variable or unknown the subject. And we'll be looking at 8 examples of that. If you're new to this channel, please don't forget to give this video a like, and if you haven't yet done it, please subscribe to this channel and hit that notification bell to be notified whenever we post new videos. Alright guys, so I want to explore the whole concept of transposition, alright? And the term transposition refers to rearranging a formula or an equation to make a given variable or unknown the subject, alright? And we'll look further more in the video what this thing is talking about. In fact, it simply means you want to get the variable or unknown on one side of the equal sign by itself, alright? So that's what we mean by subject. It simply means you want to get the variable or unknown on one side of the equal sign by itself. And as mentioned before, you'll get a better understanding of that as we go further on in the video, alright? Now we want to learn how to label an equation. So here we have an equation, 2x plus 3 is equal to 5. And the reason why this thing is classified as an equation, we have an equal sign here, alright? So we have something being equal to something. So here we have 2x plus 3 is equal to 5. Now, different parts of the equation has different titles, alright, or terms. Now, the 2 that is in front of the x right here, refer to that as the coefficient, alright. In fact, normally we say the 2 is the coefficient of the x, alright, which is the unknown in this scenario and not variable. And I'll explain why this x is a unknown and not a variable. So the coefficient would have been 2 right here, the number that is in front of the x, or the number that is multiplying the x, alright? And the x we call the unknown, or the symbol, whatever is in this place right here, refer to that as the unknown. And we call the 3 and 5 here, the numbers by themselves, we refer to those as constants, alright? Now, we are going to use this example and compare it to this one. So we're going to compare this equation to this one to get a better understanding of what a variable and a unknown is, alright? So in this case, 2x plus 3 is equal to 5. The value of x would have been 1, because only when you have 2 times 1, you will get the 2. 2 plus 3 will give you the 5. So x can only be one thing. So the value of x can only be 1. There will be nothing else that you can substitute for x here and obtain 5 as your result out here, alright? So that's why x is a unknown, alright? Only one value for the x right here. X can only be 1. Now let's look at this example here. Here we have a plus b is equal to 5. Now if we allow a to be equal to 1, then my b would have been 4. What if I allowed a to be 3? Then my b would change to 2. And if I allowed a to be 5, then my b would change to 0. Alright, so you get the gist of it. So a and b can vary. They can be anything, alright? We can substitute multiple things in this equation to obtain 5, alright? So that's why we call these variables, because the value for a and b varies, alright? So that's why I refer to that as variable. And the 5 by itself out here, we still refer to that as a constant, alright? So that's pretty much how you label an equation and the terms that are linked to an equation, alright? Alright, so here we have example 1. And here we have x plus 3 is equal to 5. Now, many times you guys see in the x, especially if you're not a lover of mathematics, and you already get frustrated, alright? But this is quite easy actually, because you have been doing algebra from you were in about grade 1, I believe. But instead of x, they normally use a box to replace the x, alright? And you normally guess the number that would go in here, alright? In this case, it would have been 2. Because you're pretty much trying to find what can I add to 3 to get the 5 right here, all right? And that is pretty much what you're dealing with here. They pretty much just change this box to an X and you got frustrated, alright? But this is something that you have been doing for a very long time. So x plus 3 is equal to 5. So in this case, by just guessing, just like how you would have to put 2 in the box right here, the value of x must be 2 because only 2 you can add to 3 and get a 5 right here, alright? So it's pretty similar. Now we came up with a procedural way how you can actually do some work, to obtain the correct result, alright? Because not in all cases will you be able to just guess the number that should replace the x, alright? Or guess the value of x. So we came up with a method to help you to better able to deal with a variety of scenarios, alright? And that's what we call transposition. So now in transposing this equation, and of course already you know that the answer is 2, but I'm going to outline the method. When you're transposing an equation, you simply do the opposite of the operation that is taking place. So here we have x plus 3. So the operation right here is addition. Now the key thing, just like the definition before, that outlined that what? This simply refers to rearranging a formula or an equation to make a given variable or unknown the subject. Now we are going to get a better understanding of that thing right now. So what we want to do here is to make x the subject. That simply means we want x on one side of the equal sign by itself. To do that, we need to get rid of this positive 3 right here. Now, in order for us to get rid of this positive 3, we are required to do the opposite of this operation, which is addition. The opposite of addition is subtraction. So the opposite of adding 3 is to do what? Minus 3, all right? So we have to minus 3 from this side. And whatever we do to one side, we have to do the same thing to the other side to keep the equation balanced. So if we minus 3 on this side, we are also required to minus 3 on the other side, all right? And if you want to understand why we did all of that, let's say we had 1 plus 2 being equal to 3 here. Now, if I should add 1 to this side, then this thing will become 4. So, of course, 1 plus 2 is 3. But if I add 1 to this side, 1 plus 1 is 2 plus 2, that's 4. If I want to make this equation balance, I also have to add 1 on this side as well. Alright? So, in order to get the equation to balance, whatever we do on one side, we are required to do the same thing to the other side to keep the equation balanced. Alright? Now, what we are going to do is to use this 3 to cancel negative 3 right there, because 3 minus 3 is 0, alright? So those things pretty much cancel out each other, and we are left with x is equal to 5 minus 3, and 5 minus 3 is 2, alright? So that's pretty much what transposition is all about. You're simply doing the opposite of the operation that is taking place, alright? And this was actually part 1 of example 1. Now let's look at part 2. Now what if we had a plus b is equal to c? Alright, so in this case we only have letters now. Now the same thing is required. What if they had asked us to make a the subject? So as explained before, that simply means we want to get the a on one side of the equal sign by itself. So the goal is to get rid of this positive b right here. So here we have a plus b. Now to get rid of this b, we have to do the opposite of adding b, which is to do what? Minus b, alright? And if I minus b on this side, I'm also required to minus b on this side as well, alright? Now let's look at what will happen when we do that. We can now use the positive b to cancel out the minus b, and a will be equal to c minus b. Alright, and this would have been our solution. Alright, so this would have been our answer, because we don't know what c minus b is, so we can't get a result from that. So our answer in this case would have been a is equal to c minus b. That simply means we would have transposed this equation for A. So we actually made A the subject, alright? So being that we're dealing with numbers, we won't get a result or a value like we got when we were dealing with numbers up here, alright? We'll end up just pretty much rearranging the equation to make A the subject, alright? So hopefully that makes a lot of sense. Now let's look at example 2. Alright, so this is what we have in example 2. X minus 3 is equal to 6, alright? And by now you should be able to integrate the concept of doing the opposite of the operation that is taking place to solve a problem like this, alright? And if you wish to try, you can always pause this video right here and then resume the video and look and see how I go about solving a equation like this, alright? So here we have x minus 3 is equal to 6. And again, if you want, what we want to do is to make x the subject. That simply means we want the x on one side of the equal sign by itself. So we are going to simply get rid of this minus 3 right here. And to remove something, we are required to do the opposite of that thing. Alright, so if we want to get rid of this minus 3, we are required to do the opposite of minusing 3, which is to add 3. And if we add 3 to this side, we are also required to add 3 to the other side to keep the equation balanced. Alright, so minus 3 plus 3, those things will cancel out, and x will be equal to 6 plus 3, which is 9. Alright, so my x would have been 9. And the cool thing about dealing with equation, you can always check your answers, alright? So what you could do is to replace the x here with the value that you got for x. So replace the x with 9. 9 minus 3 would actually give you the 6 right there, alright? So that pretty much tells us that what we did was correct, alright? Now let's look at part 2 of example 2. So what if we had t minus u is equal to v? Alright, and they ask us to make, let's say they want us to make t the subject. Alright, so they want us to make t the subject. So how would we treat with a scenario like this? Again, what we are required to do is to get the t on one side of the equal sign by itself. So what we want to do is to get rid of this minus u from over this side, alright? So here we have t minus u. So in order to get rid of the minus u, we are required to do the opposite of minusing u, which is to do what? To add u, alright? And if we add u to this side, we are also required to add u to the other side as well to keep the equation balanced. Now, minus u plus u, these things will cancel out each other and we'll be left with t is equal to v plus u. Alright, so it's quite easy actually. So once you grasp the whole concept of doing the opposite of the operation that is taking place, then algebra or transposition will be like a cakewalk for you. Alright, now let's look at example 3. Alright, so in this example, we are given 2x is equal to 6, alright? And as always, we can still integrate the whole concept of doing the opposite of the operation that is taking place. So again, we want to make the x the subject of the equation, and that simply means we want the x on one side of the equal sign by itself. And to do so, we need to get rid of this 2 right here. But first, we need to ask ourselves, what is this 2 doing to the x, alright? So 2x is the same thing as 2 times x, which simply means that the 2 is multiplying the x. So we simply need to do the opposite of multiplication, which is the operation that is taking place here. And the opposite of multiplication is what? Is division. So to get rid of the 2, I'm going to have to do the opposite, which is to divide by 2. And if I divide this side by 2, I'm also required to divide this side over here by 2 as well to keep the equation balanced. So 2 cancel 2 right here, and x is equal to 6 divided by 2, which is 3. Alright, so that's pretty much how you treat with a scenario like this. Alright, Alright, so let's look at example 4. And in this example, we have x over 2 is equal to 3. And again, the same concept applies. To remove something, we are required to do the opposite of the operation that is taking place, alright? And there's actually two ways how we can treat with a scenario like this. So the first way I'm going to demonstrate, we can actually do the opposite of this operation right here. So x divided by 2. To remove the 2, because the whole aim of this thing is to get the x on one side of the equal sign by itself. So to remove the 2, we can do the opposite of that operation, which is to multiply. So here we have x over 2. So if we want to do the opposite of this operation, which is division, the opposite of that would be multiplication. So we'll multiply by 2. And whatever we do to one side, we are required to do the same thing to the other side to keep the equation balanced. So we'll have to multiply over there by 2 also. Now we reach to a point where now we can cancel out these two 2's. So use 2 to cancel 2 right there. And x is equal to 3 times 2. And we'll get a 6 right there. Alright. Now let's look at the alternative method. So let's rewrite this problem. So x over 2 is equal to 3. Alright. And the other way how we could have done this problem, we could have simply put this 3 right here over 1. And then we could have gone on and do what they call cross multiplication. Alright, so x times 1, I'll be left with x, and 2 times 3, that's 6. Alright, so you choose which method you'd like to use. Alright, so notice it doesn't really matter which way you choose to do it. You'll obtain the same result. Alright, and you can always check your answer. So if I should replace the x with 6, 6 divided by 2 would give me the 3 right here. Alright, so if you substitute back the answer that you got, you should obtain the result, the correct result. Alright, if you're not getting that, then you did something wrong. Alright, so now let's look at example 5. Alright, so this is what we have in example 5. 2x plus 3 is equal to 9. Alright, and there is also two ways how we can go about solving this problem. Now let's look at the first thing that we can do. The first method is to actually remove those things that are furthest away from the x, because the whole objective of this thing is to find the value of x. That simply means we want to make x a subject, so we want to have the x on one side of the equal sign by itself. So first thing first, we can remove this positive 3 right here. So we have 2x plus 3. And if we want to remove the 3, we are simply required to do the opposite of this operation, which is to minus 3. And whatever we do to one side, we are required to do the same thing to the other side. So we have to minus 3 on this side as well to keep the equation balanced. Now 3 minus 3, those things will cancel out. And we'll be left with 2x is equal to 9 minus 3. That will give us a 6 right here. And then we end up with a scenario, alright, where we can now divide both sides by the coefficient of x, alright, because 2x is the same thing as 2 times x. So in order to get rid of the 2 right here, we are simply required to do what? Do the opposite of the operation that is taking place. So 2 times x, that's multiplication. The opposite of this would be division. So we can divide both sides by 2. Alright, so if I divide over here by 2, I also have to divide over here by 2 to keep the equation balanced. So 2 cancel 2, and x is equal to 6 divided by 2, and that will give me a 3. Alright, so, and again, you can always check out your answers. Alright, so if I replace x with 3, 2 times 3, that's 6, 6 plus 3, I should get the 9 right there. Alright, so this is the first way how we could have done it. Let's look at the alternative method. So let's rewrite the problem. So 2x plus 3 is equal to 9. Alright, so let's look at the alternative method. Now the first thing that we could have done is to actually get rid of the 2 right here. So we can get rid of the 2 right here. Alright, so what we are going to do, we are going to divide each term by the 2. Alright, so to remove the 2 first, I am required to divide each term by the 2, alright? So because 2x is the same thing as 2 times x, so I'm doing the opposite of that operation. But if I divide 2x by 2, I'll also have to divide each term by 2. So 3 is a term, 9 is a term. So I divide the 3 by 2 and the 9 by 2 as well, alright? So that's the first step. Now I can use 2 to cancel 2, and then I'm left with x plus 3 over 2 is equal to 9 over 2. Alright, now what is the next step? I can now get rid of this positive 3 over 2 by simply doing the opposite of the operation that is taking place. So what is the opposite of positive 3 over 2? Negative 3 over 2. Alright, and if I minus 3 over 2 on this side, I'm also required to do the same thing on the other side to keep the equation balanced. So I have to minus 3 over 2 on that side as well. Alright, now what's the next step? What we can now do is to use the positive 3 over 2 to cancel minus 3 over 2, and I'll be left with x is equal to 9 over 2 minus 3 over 2. Alright, and the rest is history from here. So being that we have common denominators, we can simply simplify the numerator. So 9 minus 3, that's 6 over the common denominator, which is 2. And 6 divided by 2 will give me a 3 right there. So this is pretty much an alternative method, and you are free to choose which way you would like to treat with a scenario like this. All right, so that's pretty much it. And I guess majority of you guys would prefer to do it like this, the first method. However, if you're comfortable with fractions, then this method won't be an issue for you as well. All right, so cool thing about math, there are more than one ways to solve a problem. All right, so either way you choose to do it, that's completely acceptable. All right, now let's look at example 6. So this is what we have in example 6. So here we were given x over 5 minus 1 is equal to 1. And again, there are two ways how we can actually treat with a scenario like this. Alright, so the first thing that we can always do is to get rid of the stuff that is furthest away, or the terms that are furthest away from the x. Alright, so what we can do is to get rid of the minus 1 first. So here we have x over 5 and we have the minus 1. Now, the key thing to note, again, whenever we want to get rid of something, we are required to do the opposite of the operation that is taking place. So here we have a minus 1. The opposite of that would be adding 1. All right. And whatever we do to one side, we are required to do the same thing to the other side. So we have to add 1 over there as well. All right. So negative 1 plus 1, these two things cancel out. And we'll be left with x over 5 is equal to 1 plus 1. And that's a 2 right there. All right. And as mentioned before, we can use two methods to solve something like this. All right. We can multiply both sides by the 5, or we can simply put the 2 over 1 and cross multiply. All right. So x times 1 would give me an x. 5 times 2, that's 10. And let me do the alternative here. So this is what we had at this point. You can also treat with this part of it. You can do the opposite of this operation. So being that x is divided by 5, you can do the opposite of that, which is to multiply by 5. And whatever you do to one side, you have to do it to the other side. So we have to multiply over there by 5 as well. All right. By doing that, we can now use this 5 to cancel this 5 right here, and we'll be left with x is equal to 2 times 5, which is 10. All right, so either way you choose to do this part of it, that's pretty much acceptable. All right, so now let's look at the alternative method. So here we have the same problem. X over 5 minus 1 is equal to 1. Now, as you would have observed, the previous method that we used was to actually get rid of the stuff that are the terms that were furthest away from the x first, then we solve the problem. Now what we could have done is to actually get rid of the 5 first. Alright, so to get rid of this 5, being that we have the x being divided by 5, we need to do the opposite of this operation, which is division. The opposite of division would have been what? Multiplication. Alright, so I'm required to multiply by 5. Now whatever I do to this term, I'm also required to do the same thing to each term. So I also have to multiply this 1 by 5. And I'm also required to multiply this one out here by 5 as well to keep the equation balanced. Alright. Now what I can now do is to use this 5 to cancel this one right here. And I'll be left with x minus 1 times 5. I'll be left with 5 is equal to 1 times 5. I'll be left with 5. Alright. Now what we can do is to simply get rid of this minus 5 now. So we have x minus 5. To get rid of the minus 5, again, we are required to do the opposite of the operation that is taking place. So the opposite of minus 5 is to add 5. Alright. And whatever we do to one side, we are required to do the same thing to the other side. So if we add 5 on that side, we are required to add 5 on the other side as well. So negative 5 cancel 5. And we're left with x is equal to 5 plus 5, which is 10. Alright. And again, as you can see, we got the same answer as the previous method. Alright. So you just choose the method that you're more comfortable with. As I always mention, cool thing about math, there are multiple ways to solve a problem. Alright. Now let's look at example 7. Alright, so let's look at example 7, alright? And there are several ways how we could treat with a scenario like this, alright? But for time's sake, I'm only going to demonstrate what I believe to be the easiest way to solve a problem like this, alright? So the first thing first, we can get rid of the terms that are furthest away from the x. So we can get rid of the positive 3 first. So here we have 4x over 6, alright? And we have plus 3. So in order for us to get rid of the positive 3, we need to do the opposite of that, which is the minus 3. And whatever we do to one side, we are required to do the same thing to the other side. So we have to minus 3 over here as well. All right. So now let's see what happens when we do that. So 3 minus 3, those things will cancel out. And we'll be left with 4x over 6 is equal to 5 minus 3. That's 2. All right. Now what we can do is to simply put this thing over 1 and cross multiply. All right. So we'll end up with 4x times 1. 1 times anything, remain the thing. So we'll be left with 4x just the same. 2 times 6, that's 12. And we already know how to deal with a scenario like this. This is 4x, which is the same thing as 4 times x. So we are required to do the opposite of the operation of multiplication. So in order to get rid of this 4, I'm simply required to divide this thing by 4. And whatever I do to one side, I'm required to do the same thing to the other side. So I have to divide over there by 4 as well. So 4 cancel 4, and I'll be left with x is equal to 12 divided by 4. That will give me a 3 right there. All right. And this is the easiest way I think you can solve this problem. All right. Of course, there are other ways how we could solve it, but we leave that for another video. All right. Now let's look at the final example of this video, which is example 8. All right. So let's look at example 8. And there are 2 parts to this question. All right. So here we have x squared is equal to 4. And in part 2, we have the square root of x is equal to 3. And again, the same concept applies, all right? So to get rid of something, we simply want to do the opposite of the operation that is taking place, all right? So let's look at part 1 first, which is x squared is equal to 4, all right? So this is part 1. Now what we can do is to do the opposite. So we pretty much want to solve for x. So we want to do the opposite of this operation right here, which is squared. So what we can do is the opposite of square is the square root. So we are going to square root x squared, and whatever we do to one side, we are required to do the same thing to the other side. So we have to square root the right hand side as well. Now when we do that, the square root sign will cancel the square sign. So we're left with x over here is equal to, and the square root of 4 would have been plus or minus 2. Alright, and you might be wondering why plus and minus 2. Alright, so what the square root pretty much gives you is the number or numbers that you can multiply by themselves to get what's underneath the square root, which is 4 in this case. So let's look at it. What and what can we multiply to obtain 4? Alright, so we can multiply 2 times 2. So we can multiply 2, positive 2 times 2, and that will give us a 4. We can also multiply negative 2 times negative 2, and that will also give us a positive 4. So we can obtain two values here. So x can either be equal to positive 2, or x can also be equal to negative 2. Alright, so that's why I have plus or minus 2 there. It simply means x is equal to 2 and x is equal to negative 2. Alright, so that explains that. Now let's look at the final part of the square root of x is equal to 3. And again, if we want to get rid of the square root sign, we simply do the opposite of that, which is the squared. Alright, so we want to get rid of the square root sign, we can simply square this thing, and if we square this side, we also require to square the other side as well. And again, the square root sign, the square sign cancels out the square root sign, and we'll be left with x is equal to 3 squared, which is the same thing as 3 times 3, and that will give us a 9 right there. Alright, so my value for x in part 2 would have been x is equal to 9. Alright, and that's pretty much how we deal with transposing equation. Alright guys, so this is where we'll end today's video. Don't forget to give this video a like, a thumbs up, and if you haven't yet done it, please subscribe to the channel and hit that notification bell to be notified whenever we post new videos. As always, thanks for watching.